In Chapter 7, Section 1, we're going to learn about how to solve systems by graphing. So by the end of this lesson, you should be able to solve systems of equations by graphing them, and to be able to analyze special types of systems of equations. So we have some vocab. Systems of a linear equation means that we're going to have two or more linear equations in the same problem. For this class, we're just going to focus on two, but when you get into Algebra 2, you'll do 3 linear equations in the same problem. In a solution, what we're looking for, our answer, is an ordered pair that makes all the equations in the system true. And remember, an ordered pair is a point, like x comma y. There's 2 special types. Sometimes we'll get down to a problem and we'll realize that instead of having one solution, like this one here, it has no solutions. There's no possible answer to it. And this is when a system has no points that makes both of the equations true. And then you have infinitely many solutions as another option, which means every single point on one line makes both equations true. So when we get done with these notes, you should be able to fill in these 2 blanks here. So before we get started on how to do this, let's talk about systems of linear equations. When you're solving these, there are 3 possible solutions. The first one is to have one solution, like we just talked about. When you have one solution, that means that your answer is going to be an ordered pair. You're going to get an answer for x and an answer for y. On a graph, this is where the lines cross. So we're going to graph 2 lines like this. This is where the solution is going to be. The next possibility is when you have infinitely many solutions. And this is when the system contains the same line, because there's infinite possibilities for solutions. So it's like if I graph one line and then it ends up being the exact same line on top of it, all of these points work for both lines. And then the last one is no solutions. And this is when the lines are parallel and they never cross. So you got 2 lines here that never have an intersection point. That means that all of the points on this line don't work in this graph and vice versa. So here's a picture of what they all look like. If you have 2 lines with different slopes, the lines are going to intersect and you're going to have one solution. If you have lines that have the same slope and a different y-intercept, they're parallel, and that means that you're going to have no solutions. And if they're the exact same, you have the same slope and the same y-intercept, it's the pink line and the blue line over top of each other. Same line, there's infinitely many solutions. So before we get into solving them, let's talk about what a solution means. So if I give you these systems here and ask you if this point is a solution, that means it has to work in both equations. So let's take a look at number 1. If I plug in the x and plug in the y, I want to know, does that equal 4? And in this case, it does. And then double check with the next equation. X equals -1. Well, the x is -1, so that works. So yes, this point is a solution to the system. Let's try this next one. Plug in my y value is 5 equals the opposite of my x value plus 4. So I get 5 equals 1 plus 4, which is true. And then do the same thing for the other one. 5 equals -1/5 times my x, which is -1. So I get 5 equals 1/5. This doesn't work. So that means that this point that we have here, this -1/5, is on this line, but it's not on this line. So because it doesn't work in both, it is not a solution to the system. Try this one on your own. So now that we know what solutions look like, we're going to learn 3 different ways to solve these systems. We're going to focus on graphing today, but there's 2 other ways that we're going to learn later this week. First one is called solving by substitution, and then solving by elimination. These ones use algebra, where this one is more visual. So we tend to do this one first so we can actually see where the solutions are, and then we get into solving for x kind of stuff. So let's do a problem. Solve the system by graphing, check your solution. So what that means is when we get done, we can check it just like we did with these problems here and make sure that it works in both equations like we did over here. So let's graph this first one, y equals negative 3x minus 3. So it's in y equals mx plus b form. I'm going to start down here at negative 3, and then my slope down 1, 2, 3 over 1. 1, 2, 3 over 1. Remember, you can make as many points as you want. The more you make, the straighter your line is going to end up being, which is really going to help us out for these problems. So make sure you draw your line nice and straight. And now let's work on the other one. So we're graphing two different equations on the same line. So this one I'm going to start at 2, and down 1 over 2, down 1 over 2. Then go up 1, backwards 2. And something special just happened. I had these two lines cross, and they crossed at a point. That point's right here. The point is negative 2, positive 3. That means that this solution should work in both equations. And that means if I plug in x equals negative 2 and y equals 3, it should work for both. So plug it in and check. When I plug this in to the first one, I want to know if 3 is equal to 6 minus 3. And it definitely is. So let's plug it in the next one. My y value is 3. Negative 1/2 times negative 2. So this gives me positive 1. And if I add 2 more, I get 3. So this double checks it. I know my answer is right. I can box it up. I have one solution. Let's try another one. So this first equation they give us is in y equals mx plus b form. Nice and easy to graph. I'm going to start at 1. Go down 2 over 1. Remember, the more points you make, the straighter you can get your line. And since that's so important, I'm going to make a bunch of points. And then this next one is in standard form. And I'm going to solve it with intercepts. Remember, if I want to find where it crosses the y-axis, you cover that up. So it's going to cross the y-axis at negative 4. Y-axis at negative 4. Then I can do the same thing for the x. Cover that up, and I get that it crosses the x-axis at negative 2. So at first glance, these look like they don't cross anywhere. For this one, to make sure that I did this right, that these don't cross anywhere, what I want to do is take this blue one and make sure that my slope is exactly the same and that my y-intercept is exactly the same. Graphing is very visual, but there's lots of mistakes that can be had when we graph. So we get this, divide everything by 2, so we end up with this blue equation looks almost identical to the red equation. We have the same exact slope, negative 2, and a different y-intercept, 1 and negative 4. So remember, that means they're parallel. So this would mean that this has no solutions. There is no spot on any of these graphs that will work for both equations. Let's try another one. So the first one is kind of in y equals mx plus b form, and it's definitely not in standard form. So what I'm going to do is turn this into y equals mx plus b. So divide this by 5, divide this by 5, and that too. I get y equals a 1/5 x plus 9. So if I go to graph this, I'm going to start up at 9, go up 1 over 5, and I can even go down 1 and backwards 5. Connect my dots. And then I go and I look at this next equation, and it looks exactly the same as this one. So I could take the time to graph it, but I know it's going to be exactly on this line. So because you have the same slope and y-intercept, these are the same lines, that means there's infinite solutions. Every single point on the first line works in the second line because they're exactly the same. So you should be able to solve systems of equations by graphing and analyze the special types, the ones that we just did, the no solution and the infinitely many solutions. So solve this system by graphing, make sure you check your solution, and then go back and finish this one on your own if you haven't already. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.